Good morning, friends. My name is Shyam from Lagurme. Today, I am going to discuss about the topic complex numbers. Yes. Okay. Complex numbers. When we see the word complex number, first thing comes in our mind is what is complex number? Complex number क्या है? Why the complex number came into our picture? Right? Why the complex number came into our picture? There are many equations whose roots are real. There are many equations. There are many. For example, if we take the example x square minus 4 is equal to 0, x square is equal to 4, right? X is equal to plus or minus 2. There are many equations like this. But now we are going to see the equations whose roots are not real. ऐसे भी बहुत से equations हैं जिनके roots real नहीं है. Yes. If we take the example, suppose x square plus 1 is equal to 0. This is the example, x square plus 1 is equal to 0. This can be written as x square is equal to minus 1. Is there any real number whose square is minus 1? क्या ऐसा कोई नंबर है, रियल नंबर है जिसका स्क्वायर माइनस 1 आ सकता है? No, there is no such a number. There is no such a number. Therefore, complex number comes in our picture, right? Complex number है. अब now, what is complex number? Complex number क्या है? Complex number क्या है? Our great mathematician Euler introduced this number first time. This is a Greek letter iota. This is a Greek letter iota. This is equal to root of minus 1. This is equal to root of minus 1. And complex number is of the form, any complex number is of the form a plus bi. Here, any complex number usually denoted by z. Any complex number usually is denoted by z, right? Any complex number. Here, in this is known as complex number where a comma b, a and b belongs to real numbers. A comma b belongs to real number, and this iota is nothing but this is equal to root of minus 1. Iota is nothing but root of minus 1. Okay. Now, what is this is like this. Iota is all the set of complex number is denoted by C, capital C. All the set of all the complex number is denoted by capital C. As all the real numbers are denoted by capital R, therefore capital C is nothing but same. A plus B R, where A comma B belongs to real number and iota is equal to root of minus 1. Iota is equal to root of minus 1. Now, here the C means all the complex set of all the complex number and Z means any complex number, one complex number. Okay. Now we go the further. Now here this A is known as real part of the Z, real part of the complex number. Means this is real part of the complex number. Now, and it is denoted by real part of complex number is denoted by real of Z, which is equal to A. Okay, real part of Z is denoted by real of Z and which is equal to A. And here this is known as imaginary part of complex number, means imaginary part of Z, and it is denoted by I m of Z, that is equal to D. This is known as imaginary part of complex number and this is written as this. Now we see if real part of any complex number, real part of any complex number, real part क्या है इसमें a, real part क्या है ये complex number में a. If real part of any complex number is equal to 0, then z is equal to ib, z is equal to ib, and this is known as purely imaginary number. This z equal to ib is known as purely imaginary number, and here again one condition is there. Here b is not equal to 0. Okay, if here b is equal to 0, then this z is purely real number. It will become z equal to 0, and that will be real number. But if b is not equal to 0, then this z is equal to ib, and this is known as purely imaginary number. Now, if here b is equal to 0, now in this complex number, if b is equal to 0, that means b is equal to 0, then z is equal to capital A, and this is known as purely real number. Purely real number. Now, we know that real numbers are represented on real axis. No, right? Real numbers real axis पर रिप्रेजेंट करते हैं. तो अब इसके लिए भी कॉम्प्लेक्स नंबर के लिए भी कुछ चाहिए जिसके ऊपर हम कॉम्प्लेक्स नंबर को रिप्रेजेंट कर सकें. Okay. In the complex number, there is known as complex plane where we can represent complex numbers. Where we can represent complex numbers. Complex plane is nothing but it is 2D geometry or 2D space. As we draw 2D space like this. In 2D space, this is x-axis, right? This is x-axis, this is y-axis. In complex plane, this x-axis is known as real axis. ये x-axis जो है इसे real axis कहा जाता है in complex plane. Okay, and this y-axis is known as imaginary axis. ये y जो है, this is known as imaginary axis. Okay, any number. Suppose we take z1 is equal to -1 minus 1, right? If we have to represent this complex number in this complex plane, then we know that this is 1, this is 2, this is 1, this is 2. This is negative x-axis, this is -1, this is -2. We draw this as 0, this is -1, this is -2. Right? Now we have to represent this complex number. Z equal to -1, -1. Where is -1? -1 is here. Minus sign means imaginary axis. Okay, this is here. This is the point. We require point. Z1 is this. We can represent any complex numbers in this complex plane. Okay. Yeah. Now, when the two complex numbers are said to be equal, दो complex number को equal कब कहा जाता है? If we take two complex numbers, suppose z1 equal to a plus bi and z2 equal to c plus bi. ये दो complex number को equal कब कहा जाता है? When their real parts, means real parts of z1 is a, right, and real part of z2 is c. Their real parts are equal. At the same time, their imaginary parts must be equal to each other. It means a equal to c and b equal to d. The imaginary part is here. Imaginary part is b. Here imaginary part is d. Therefore, b is equal to d. If this condition is true for any complex number, then the complex number, those complex numbers are said to be equal. Now, addition of two complex numbers. Addition two complex number. Suppose the two complex number is same z1 and z2. We have to add them. Then z1 plus z2 is equal to a plus bi, and z2 is equal to c plus di. z2 is equal to c plus di. Okay. Then we have to add them. Then we have to consider real part of z1 and real part of z2, that is a plus c, and imaginary part of z1 and imaginary part of z2, that is b plus I plus b plus I, that is equal to a plus c. I taking I from common, I is taking common from both. We get this. Then this is known as real part of z1 plus z2, and this is known as imaginary part of z1 plus z2. This is like this. This is a. Okay. A plus c plus I plus b plus d. This. Now we have to subtract two numbers. Subtraction of two numbers. That numbers are, suppose z1 is equal to a plus bi and z2 is equal to c plus di. ये दोनों का subtraction. Okay. We have to z1 minus z2, which is equal to a plus bi same, minus z2 is c plus di, which is c plus di. Z. Okay. Multiplying minus inside, we will get a plus bi minus c minus di. Therefore, combining real part of this and this, and imaginary part is this. Writing then a minus c in one bracket. Here we can take I common from both imaginary parts. Therefore, this is equal to plus I common in the bracket b minus d. Z minus real part of z minus z2 is a minus c, and imaginary part of z1 minus z2 is b minus d. Like this. Now we go to the power of I. What is the power of I? Right. Power of I. I is equal to root of minus 1. We know that. Now I square is equal to root of minus 1 into root of minus 1. Any root we can know this. This is equal to minus 1. I square is equal to, I square is equal to root of minus 1 into root of minus 1, which is equal to minus 1. I square, Now I cube is equal to root of minus 1 into root of minus 1 into root of minus 1. Here, this is equal to minus 1. Minus 1 into root of minus 1. Then this is equal to I, and this is minus. Therefore, minus I. Right? I raised to 4 is equal to nothing but I cube into I. Here from this, I cube is equal to minus I into I. Therefore, minus I in the bracket square. What is the value of I square? From here, I square is equal to minus of minus 1. Minus 1 from here, I square is equal to, therefore this is equal to 1. Now in general we can write it as I raised to 4n, which is equal to, if we take again one power, then this will become I raised to 5. And I raised to 5, if we take I raised to 5, which is equal to I raised to 4 into I, which is equal to I I raised to 4 is 1, and this same I is to be written as this. Therefore, in general, we can write it I raised to 4n, which is equal to 1 I raised to 4n plus 1, which is equal to, from this we can see what is the value of I raised to 4n plus 1. This can be written as I, right? Because I raised to 4n is equal to 1, remaining I. Now I raised to 4n plus 2, which is equal to, what is the value of I square? Same as I square. I square is minus 1. 4n is 1, same I square. Therefore, I raised to 4n plus 3 is equal to I raised to 4n into I cube, which is equal to I raised to 4n is 1, I cube is equal to